Okay, welcome. Today we'll be looking at the shortest distance between a point and a line. Because you might be given a point and a line and you're asked to find the shortest distance between perpendicular distance. Yes. So that's the shortest distance. So let's represent it with a diagram. So we'll have this diagram. As you can see, this is my point with coordinate x1, y1. Why this is my line with equation ax plus by plus c equal to 0. So we are going to use it to derive the formula, and I told you the distance, the shortest distance will be the perpendicular distance. That's why you are seeing this 90 degree. So how do I start? I'll start by drawing a line to this y-axis to intersect this line at a particular point, and also draw a line again parallel to y-axis that will intersect the x-axis, that will have the same common point as the line and the x-axis. With that, we form a right angle triangle by joining the other remaining sides. Okay, let's join. Okay, we've drawn the line that is parallel to okay, this is the line. These two lines are parallel to our y-axis. So this line is parallel. These two lines are parallel to the y-axis. So if we label this A, B, C, D, and E. As you can see, as this is parallel to our y-axis, so this should be 90 degrees. Yes. The next thing is because we need to get this distance, this and this. So from our equation of line given, from this equation, is A x plus by plus c equal to 0. If we now make y the subject of formula, making y is the subject of formula, this goes here to be minus ax. This goes here to be minus c. So remember, b is the coefficient of y. So dividing both sides by. So this is our y. We've made y the subject of formula. So to get the coordinate of b, the coordinate of b is simple because it will have the same, since it's parallel, it will have the same x coordinate, but the y value is now if you substitute the value of x1 in this, you now get y1. You get x1 y1. So this is minus ax1 minus c over b. So that's my coordinate of b. And why did we do is to get, because we're trying to compare these two right triangles. So I want to get the hypotenuse and also get the hypotenuse. So we'll now solve that. With that, it will give us the distance we are looking for. So we see that AB, from this you see that AB is just the difference between the coordinate, the y coordinates, which is, so from here to here is y1. Remember, is distance. Distance is always positive, so absolute value y1 minus this. That's the difference between the y coordinates of A and B. So which is y1 minus this, and both has minus, so it will bring us, so it will it will come out to be positive, plus ax1 plus c over b. So that's it. So the distance AB is that. Why coming here? Look at this. This is the line, which is the same as y equal to this. And looking at this line, this is the slope. Changing y over changing x. So which is changing x is the denominator, which is b. And remember, distance is positive, so we use absolute value. Y for y is a. And again, looking at the two triangles, since this line is parallel to this, the angle here is the same as the angle here by corresponding angle theorem. So now see that these two triangles are similar. Triangle ABC and triangle BED, they are similar. So we see that triangle ABC is similar to A corresponds to B here. So triangle B, and B corresponds to E, so BED. By right triangle similarity postulate. By right triangle similarity theorem. So the two triangles are similar. So which implies that the ratio of their size must be proportional, the corresponding size. So if we call the distance, we are looking for the distance here, AC, which is, let's call it D. Let's call ACD. So we see that D corresponds to, that's 1909. So D corresponds to BD. That's AC corresponds to BD, which is so D over BD, which is absolute B, is equal to the hypotenuse here is absolute y1 plus ax1 plus c over b, all in absolute value, over why the hypotenuse here by Pythagorean theorem is always the sum of the squares, the square root of the sum of the squares of these legs. So BD is square root a squared plus b squared based on Pythagorean theorem. So here will be square root of the sum of the squares of a and b, and we are looking for D. So our D will be equal to this times this over, which is absolute B times absolute y1 plus ax1 plus c over b, all in absolute, over square roots a squared plus b squared. And you know b is also absolute, so if we multiply, so okay, let me just go to the next line. So we see that D is equal to, we can write this as absolute B times B is the same as absolute B, yes, it's positive. So this over 1 LCM, so it's now by1 plus ax1 plus c over square root a squared plus b squared, which is, if you multiply this, you now get this, which is absolute ax1 plus by1 plus c over square root of a squared plus b squared. So this is now the distance between, that's the formula. So this is the formula for distance between, this is the distance between x1 comma y1 and line ax plus b y plus c equal to 0. So whenever you are given that, just substitute the value of this here, absolute, over the square root of that. So look at this question. So we are asked, find what is the shortest distance between this point and this line. So from here, it's simple. We've known our formula that d is now the absolute of ax1 plus by1 plus c squared. So from here, you see that the line is 2x minus 5y minus 7 equal to 0. So you must transform it to have in form of ax plus by plus c equal to 0 before you start. So from here, our a is 2 and our b is minus 5, our c is minus 7. So the distance is now equal to, therefore the distance is now equal to absolute of 2. x1 here is minus 2 minus 5 times, because b here is minus 5, y1 is 3 and c is minus 7, on in absolute value over square root of 2 squared plus minus 5 squared. So which is, this minus 4 minus 15 minus 7 over 4 plus 25, which is 29, square root of 29. Remember, absolute. So minus 4 minus 15 is minus 19. Minus 19 minus 7 is minus 26. So absolute of that is 26. So this is 26 over square root 29. So that's the distance. So it's a very nice formula. Thank you.